if you are new here, please don't forget to hit the subscribe button and also hit the bell icon so that you will not miss any video from this channel. So friends, we are going to solve a problem from South Africa Olympiad 2019. The problem is very interesting. Okay, so the problem is, let Z be the set of integers. Determine all functions a such that for all integers a and b, this condition will be satisfied. F of 2a plus 2 into f of b equal to f of a plus b. Notice that here f is defined on z, right, set of integers, both domain and range. So friends, if you notice this function f, right, that is f colon z arrow z, it looks linear, right? So if we can prove that f is a linear function, we can get the solution easily, right? So let's try to do that. So for that, let's substitute a by 0 first, right? First a by 0 and b by n plus 1. Okay, so then the equation will be f of 2a, that is f of 0, plus 2 into f of b, that is 2 f of n plus 1 equal to f of a plus b, that is simply n plus 1, because here a is 0, right? And let's now substitute a by 1 and b by n, right? Then we will get f of 2 plus 2 into f of b, that is f of n, right, equal to f of n plus 1, right? And notice this f of n plus 1 and this f of n plus 1, they both the same, right? So we can equalize both this equation, right, this and this. So we'll get f of 0, right, plus 2f of n plus 1, right, equal to f of 2 plus 2 into f of n, right? So guys, now let's rearrange it. Okay, so 2 f of n plus 1, right, minus 2 f of n equal to f of 2 minus f of 0, right? So now we can take 2 common, so this will be f of n plus 1 minus f of n, and we are going to take 2 on right side, so this will be half of f of 2 minus f of 0, right? And notice it, this term is a constant and it is possible only for a linear function. I am gonna prove it after a while. So basically this f of n plus 1 minus f of n, this is a constant, this must be a constant, right? And guys, here we did, right, because we have to prove that fn actually is a linear function, because the differences of any 2 points on a linear function is a constant, as the result can depend only on m. Now if you have doubt, okay, if you are not clear with it, so let me clarify you. Okay, so let's take a linear function in the form of slope intercept, that is y equal to mx plus c, right? We everyone know this is y intercept and this is slope, right? This is slope and this is y intercept. Okay, and so f of x, we can take a linear function f of x mx plus c, right? Now do f of x plus 1, right, equal to m of x plus 1 plus c, and f of x, that is simply mx plus c. Now if you do subtract f of x plus 1 minus f of x, you will get only m, right? So that is a constant. If it is a quadratic function or higher degree of function, then this will not give you a constant value. For example, just take a quadratic function f of x as x square plus bx in the general form, right? And if you do f of x plus 1 minus f of x, you will get something like 2ax plus a plus b. So that is not a constant, it's not a constant, right? So guys, we prove that the function fn is actually a linear function, right? This is totally a linear function, right? So in linear function, let's take it f of n as mx plus c, or any form you can take, right? mn plus k, you can take this, where m and k, they are arbitrary constant, okay, arbitrary constant. But now we have to determine for the which choices of m and k, okay, this will be satisfied. So we have to find out the set of functions, right? So friends, our given equation was f of 2a plus 2f of b equal to f of a plus b, right? So from f of n equal to mn plus k, okay, we will find these values. So f of 2a, this will be simply m and n is, that is 2a into 2a plus k, right? F of b simply m b plus k, right? Here guys, n is the dependent variable, okay? Dependent variable, remember it. And f of a plus b, that is simply m of a plus b plus k, right? Then simply f of a plus b, right? This will be m of a plus b plus k, right? Plus k. So now we'll put these values in that equation. We'll get 2ma plus k plus 2 into f of b, that is 2mb plus 2k, and on the right side this is simply m of a plus b, right, plus k, close parenthesis, plus here another k, right? So guys, now we are going to simplify it. First of all, you can cancel this k and this k. We will get 2ma plus 2mb. So from here we can take 2m as a common, then it will be a plus b, then plus 2k equal to, we can simplify it, m square of a plus b plus mk. Now let's take everything on left side. So this will be 2m of a plus b minus m square of a plus b, right, plus 2k minus mk equal to 0. So now let's take a plus b from here as common. So we'll get a plus b, okay, parenthesis 2m minus m square, close parenthesis, plus, and from here we can take k as a common, that is 2, remaining will be 2 minus m equal to 0. So now from here again you can take m as a common. So we'll get actually m of a plus b, right, 2 minus m plus k of 2 minus m equal to 0. Now 2 minus m and 2 minus m, so let's take it common. So 2 minus m, okay, and this will be simply m of a plus b, right, plus k equal to 0. So friends, from here you can understand either m equal to 2, or from here m of a plus b plus k equal to 0. So friends, if m equal to 2, then the function will be f of n, right? So 2n plus k, right? And if m of a plus b plus k equal to 0, then the set of function will be f of n equal to 0. Okay, because basically n is taking a plus b, just integer value. Okay, so in this form, for this case, the set of functions will be, okay, f of n equal to 0, because a plus b, they both are integers, so they can take any integers, right? So these are the set of functions, right? So I hope friend you like this video. If you like this video, please don't forget to hit the like button and share it with your friends so that they can also get the benefit. See you in the next video. Till then, take care of yourself and keep learning.